Hello. Let's continue with our discussion on salt questions. This time the question is taken from MRSM paper 2003, the third structured question. Okay, so let's write equations again. The more we write equations, the more we practice, the better we get, and the more questions we can answer. So magnesium oxide, okay, add nitric acid, okay, and we will get, just change partners. Alright, so now Mg2 plus will partner with NO3 negative. Okay, so how do I write it so easily? Mg2 plus NO3 negative. If this is 2 plus and this is only 1 negative, therefore we will need 2 nitrate ions. Okay, when we put them together, it becomes Mg and 2 nitrate ions. Okay, and what's left is the H and O. H and O will always become water. So the next thing to do is to balance your equation. So because there are 2 N's on the right side of the arrow and 2H also on the right side of the arrow, so you put the 2 in front here. Okay, so now you have 6 O's, okay, plus 1 more O here, 7 O's. Same thing on the right side of the arrow, we have 6 O's plus 1 O. So the left side of the arrow must always balance with the right side of the arrow. Okay, so solution of salt P, this is the solution, right? Magnesium nitrate is the solution. Okay, the next step is this MgNO3-2, right? MgNO3-2 must add a solution S, okay, this is solution S, to become magnesium carbonate. Alright, so what must we add, alright, to become magnesium carbonate? Now think about it. Magnesium carbonate. Is magnesium carbonate soluble or not? Alright, so once again, if you check your textbook, you will notice that, not this page, you will notice that all carbonate ions are insoluble except for sodium, potassium and ammonium, right? Because we already learned right at the bottom here that all sodiums, all potassiums, okay, and all ammoniums must be soluble. So carbonates are all not soluble except for these 3: sodium, potassium, ammonium. Alright, so therefore, let's go back to the question. Okay, let's go back to this question. Therefore, we can see that this is an insoluble salt. It is a precipitate. Okay, so how do we form a precipitate? How do we form an insoluble salt? Okay, we use the double decomposition reaction, meaning we must take 2 solutions, add them together so that it becomes one soluble and one insoluble. So how do we make MgCO3? We already have Mg here. Okay, this solution S, it needs to be something carbonate. Alright, something carbonate. And the safest to use is either sodium carbonate or potassium carbonate, because all sodiums are soluble, all potassiums are soluble. So let us use sodium carbonate. Now if we use sodium carbonate, you can see how the ions change partners. Magnesium will change partner to partner with carbonate, that's why you get magnesium carbonate. And this sodium will change partner and it will partner with nitrate. Okay, it will partner with nitrate to become sodium nitrate. Now when it becomes sodium nitrate, so you can see sodium nitrate is a solution, and then magnesium carbonate is the precipitate. Alright, so let's make sure we balance the equation. There are two sodiums, so we put a 2 in front. Okay, that will also give you 2 nitrates, which is 2 nitrates over here, and it's balanced. Okay, the left side of the arrow must balance with the right side of the arrow. Okay, let's answer some questions. Chemical equation for the production of P. Okay, this is P. So the chemical equation is already here. MgO plus 2HNO3 gives you magnesium nitrate and water. Second question, describe briefly how solution P can be prepared. Okay, so how do we prepare solution P? So we want to, okay, you can see this is an acid, alright, and this is a solid. Okay, it's a solid, it's not a solution. Okay, so what we want to do is, we have a beaker, okay, and the beaker will contain nitric acid. Okay, and then we want to heat up this nitric acid, heat gently, okay, on a tripod stand with a Bunsen burner, and we want to add MgO. Okay, MgO is a solid, so it's a spoon. Okay, solid MgO. Okay, add it into the acid slowly, little by little, and then keep stirring until the MgO does not dissolve anymore. So the MgO is in excess. Okay, so that is how we prepare this solution of magnesium nitrate. Okay, so you want to write down the answers. Okay, we add MgO, okay, little by little into 100 cm cube of 0.1 mole per dm cube. Actually, it doesn't matter how much lah. Right? If you are using a beaker, you can use 100, you can use 150, you can use 200. Right? The molarity you can use 0.1, 0.2, 0.5. Okay. Nitric acid in a 200 cm cube beaker. Alright, so because we are using 100 cm cube, you cannot be using a test tube. Alright, so we use a beaker lah, and the beaker should be, you know, the 200 cm cube or 250 cm cube beaker that we normally use in the lab. Okay, and we add this MgO little by little until excess. Okay, so that's 1 mark. Alright, so after you add until excess already, your beaker, you will have nitric acid, you have MgO in it, you also have the product, which is magnesium nitrate. Okay, so right now you just want to, the reaction is complete already. When the reaction is complete, it means there will be no more nitric acid lah, but there will still be this excess of MgO together with the product, which is magnesium nitrate. Okay, and the excess MgO that we put in. So you don't want this MgO. Okay, this excess MgO, you don't want it. You only want magnesium nitrate, because it says how solution P, okay, which is magnesium nitrate, how is it prepared? Okay, so we don't want this MgO. What do? We filter it out. Alright, so filter the mixture. Okay, and what will happen is after you filter, this residue here is the MgO that you don't want. Okay, and the filtrate. Okay, this is the filtrate. This is the filtrate with only magnesium nitrate. Okay, filter the mixture, and the filtrate, which is this one, is MgNO3-2, magnesium nitrate. So 2 marks here. Okay, name solution S that needs to be added to P. Okay, so let's look at the question again. What is solution S? Alright, so we have mentioned just now sodium carbonate, or you can use potassium carbonate. It's the safest because all sodiums are soluble, all potassiums are soluble. So they want the name, so you have to write name. So I'll write sodium carbonate. Okay, write an ionic equation for the formation of magnesium carbonate. So magnesium carbonate, let's write that first. Magnesium carbonate, we want to form magnesium carbonate. Ionic equation means what ions form this precipitate. Okay, this is a precipitate, that's why we can do shortcut which is just take the Mg, right, take the carbonate. Okay, these two ions form the precipitate magnesium carbonate, MgCO3. So this is the ionic equation. It shows the ions. Okay, next question. This question says that nitric acid reacts with excess magnesium oxide. Okay, this is actually the same thing. We are just rewriting the equation for easy reference. Okay, balance the equation. Okay, so it says 50 cm cube of nitric acid. So cm cube is volume, 50 cm cube. Mole per dm cube, that's molarity, 0.5 mole per dm cube. So with the information that we have in any calculation question, the first thing you must always do is find number of mole. So in this case, number of mole of nitric acid. So we use the formula mV over 1000. Okay, so m is molarity, mole per dm cube. V is volume, cm cube. Now, because this is cm cube, we need to change it to dm cube. So we divide 1000. So this one will be 0.025 mole. Alright, so that's the first step. Now they ask you to calculate the number of moles of salt P. Salt P is magnesium nitrate. So we want to compare the ratio of these two. Nitric acid, we have the information, the number of mole. Whereas magnesium nitrate is the answer that we want. The number of moles of magnesium nitrate. Okay, we want that answer. That's why we compare these two ratios. So step 2 is to compare from the equation. Okay, you can see that 2 mole of nitric acid ratio with 1 mole of magnesium nitrate. Okay, and from your calculation from the experiment, we have calculated that 0.025 mole of nitric acid, okay, will ratio with what? So if 2 becomes 1, so therefore 0.025 will become 0.0125 mole of magnesium nitrate. Half, 2 become 1 is half, so 0.025, half of that is 0.0125 mole. Okay, so that is the number of moles of salt P formed. Okay, let's look at the next question now. Calculate the maximum mass of magnesium carbonate that can be formed. So we look back at the diagram. Alright, so from magnesium nitrate, okay, it will combine with an S solution to become magnesium carbonate. So the question is asking, what is the maximum magnesium carbonate that can be formed. Alright, so okay, so we need two equations here. Alright, the first one is the magnesium carbonate. Magnesium carbonate is formed by, we have written this earlier. There's a reason why the questions ask us to write this, because you need it for calculations. Okay, and this Mg2 plus comes from where? The Mg2 plus actually comes from, if you look back at the diagram, this Mg2 plus comes from magnesium nitrate, right? Magnesium nitrate is from the first equation. Okay, so this magnesium nitrate, in the question before this, we have already calculated. Okay, the magnesium nitrate number of moles is 0.0125. Now, if magnesium nitrate 0.0125, okay, so let's use this equation. So this Mg2 plus, alright, is from this Mg nitrate. Okay, this Mg nitrate, if you open it up, it actually consists of magnesium ion and nitrate ion, and two nitrate ions. Okay, so this Mg2 plus is this Mg2 plus, and this Mg2 plus we can ratio with the magnesium nitrate. So before this, in my previous slide, we calculated 0.0125 mole. Okay, so let's write it down. This is 0.0125 mole. So if this, in the equation, 1 mole and 1 mole. So in the experiment, 0.0125 mole and 0.0125 mole. This all ratio, 1 mole and 1 mole in the equation. So therefore in the experiment, 0.0125 mole and 0.0125 mole. So this Mg2 plus is the one that reacts with carbonate ion. So therefore these two are the same, Mg2 plus and Mg2 plus. So this is 0.0125 mole. Okay, and if this is 0.0125 mole, okay, so from the equation we can see that 1 mole of Mg2 plus will give you, because the answer that you want is magnesium carbonate. Okay, so that's why we are comparing these two. Mg2 plus, you have the information. Magnesium carbonate, you want the answer. So we want to compare these two. 1 mole MgCO3. Okay, so from the equation, you can see 1 mole Mg2 plus ratio with 1 mole MgCO3. Okay, and from the experiment or from your calculation, we know that we have used 0.0125 mole of Mg2 plus. So therefore, the amount of MgCO3 that is produced will be the same, 0.0125 mole MgCO3. So with this number of mole, okay, we are able to find mass, right? So mass of magnesium carbonate, we use the triangle. Okay, how do we find mass? We take number of mole times molar mass, or calculate, add up all the RAMs. So mass is number of mole, which is from here, 0.0125, okay, times molar mass. Now this is the molar mass that you must add up. So what is RAM for Mg is 24. RAM for carbon, okay, refer the question, is 12. The RAM for oxygen is 16, and there are 3 oxygens, so 16 times 3. Okay, so calculate lah. Use your calculator. This one total up will be 84, and the final answer is 1.05 gram. Okay, so this is the answer. Okay, last question. Magnesium carbonate can be converted to magnesium oxide. Describe how this conversion can be done. Now remember in your textbook we did something on heating carbonates. Alright. So this page, page 186, 185, 186. Or is it 186, 187? Okay, take a look at your textbook. So we did this experiment, or I showed you the video of the experiment of when we heat up carbonates. Okay, when we heat up carbonates, what will happen is the carbonate will decompose. Okay, so in this case we have magnesium carbonate. So the magnesium carbonate, magnesium carbonate will decompose when it's heated strongly. And when it's heated strongly, you see this carbonate will always give you carbon dioxide gas. And what is left is the magnesium oxide. Okay, so back to the question again. Magnesium carbonate convert into magnesium oxide. So this is the magnesium carbonate, that you heat up. Carbonate, you always get carbon dioxide, and what's left is the magnesium oxide. So how do we convert to magnesium oxide? Okay, we heat it strongly. We heat magnesium carbonate strongly, and it will decompose to magnesium oxide and carbon dioxide. So that's your 1 mark. Heat magnesium carbonate strongly. The magnesium carbonate will decompose to magnesium oxide and carbon dioxide. Okay, so that's all for this question.